This conference will now be recorded.
Very good evening, students. Today we'll be discussing numerical problems from JEE Main 2021 26th August paper, and that was in the second shift. So in this series of PYQ discussion lectures, we have covered so far many questions from JEE Mains papers. So today in this session, I'll be discussing the questions asked in this particular question paper on the topics of 11th session. Okay, the topics from the 11th class. Okay, so let us start our discussions. So the first question says a refrigerator consumes an average 35-watt power to operate between temperature minus 10 degrees Celsius to 25 degrees Celsius. If there is no loss of energy, then how much average heat per second does it transfer? So this question is related to refrigerator. As you know, if I draw a flow diagram, heat flow diagram, how it happens? Suppose this is the cold reservoir, okay, cold reservoir or cold environment from where the heat is being extracted by the refrigerator, and let us say that amount of heat is QC, and what it does, it actually reject this amount of reject the heat from cold reservoir to the hot reservoir. Okay, let us say the temperature of cold reservoir TC and temperature of this hot reservoir is TH, and the heat the refrigerator rejects here is QH. Okay, QH. So according to second law of thermodynamics, it is possible only when some work is done on the refrigerator or some energy is supplied from external sources to the refrigerator, and that is given here, the average power. Okay, so that is 35 watt is given to the refrigerator. So when there is no loss of energy, how much average heat it can transfer from this cold reservoir to hot reservoir per second, that you have to find out. So for this, you have to find out the beta, that is the coefficient of performance. Okay, coefficient of performance, COP. So we have to find out what is this beta. This is not the efficiency, this is actually coefficient of performance. Okay, coefficient of performance, beta. So how do we write this? It is actually little bit different. Suppose you write in case of Carnot engine, heat engine, you write work done, work output or output divided by heat input, like that we write, isn't it? But here it is actually ulta, just opposite. See the heat it extract, okay, heat extracted from the cold reservoir divided by the power it has been given to. Okay, all right, so this is actually for the work done or the energy given to this reservoir. For that, it can be written in terms of this also, Tc by Th minus Tc. Okay, in terms of temperature. So Tc is the temperature of the cold reservoir in Kelvin unit. Okay, so if I get, okay, so I have to get the Tc. So you have to write 237 plus of minus 10 degrees centigrade. This will give you 263 Kelvin. Similarly, Th you will get 273 plus 25 degrees centigrade, which will give you 298 Kelvin. Okay. Now, if we put these values here, then beta how we will be getting? What is the value of beta we will get? Beta is 263 divided by 298 minus 263. So this is 263 divided by 5. This is 3. Okay, 35. So beta we have got. So we have to actually find out how much heat. That means, see, this QC we have to find out. QC we have to find out. So let us write this beta in terms of QC by W. Okay, this is QC by W, or QC is equal to 263 by 35 into W. W is the average energy that has been sent per second. So that is 35. This is watt means joule per second. I can write, isn't it? So watt means joule per second. So look, this two will cancel each other, and then I'll get this as 263 joule per second, right? So option D will be the correct answer for this question. Okay, so this is an important question from thermodynamics. Generally, one question from either from refrigerator or heat engine using Carnot's theorem or Carnot's, like, concept of Carnot's engine you have to solve. So better to remember this formula, that is QC by W or TC by TH minus TC. Okay, all right, so we'll go to the next problem. So this problem is from vector. This is very important because one question may come from vector section in the kinematics part. All right, so here the question is the angle between A and A minus B. Here you have been given the vector A, vector B. So this is B, this is A. So if you actually write A plus B, so this is actually A plus B. A plus B vector is this one. Okay, this is A plus B vector. Whereas we have to actually find out the angle between A and A minus B. Okay, so you look, generally we write A minus B vector as this. In vector there is no subtraction in reality. The subtraction is written in this way. Okay, we'll do the vector addition but taking the direction of B in the opposite direction to its original direction, so that we get minus B. So this is B, so this is minus B. You can see the dotted line here. So this is minus B vector. If I just extrapolate this, so you look, this the resultant will be kind of this direction, okay, somewhat in this direction, okay. So look, this particular vector, this one is actually a minus b. This is the resultant, okay. So these are parallel, you can see this, these two are parallel, okay. This is the resultant are a minus b, this is also a minus b. So I'm just erasing this part, but you can understand this is a minus b, right? So I have to find out what is this angle beta. What is this angle beta? Okay, we have to find out what is this angle beta. Okay, first of all, you look, this angle is 120. That means how much is this? This is 60 degree, right? This is 60 degree, isn't it? All right. Let me now do one thing. Let me just give some name here. Suppose this is P. This is Q. Okay. And let us give this name as R. And here I'm just dropping a perpendicular on this PQ from this R. Okay. Let us write. Let us give this name of this point as S. Okay. Now you can understand this is perpendicular, so this is a right angle triangle. Both are actually right angle triangles. Okay, both are right angle triangles. Now I have to find out what is this angle beta. Let me write down as tan beta. What is tan beta? From this figure, I'll just take this triangle PRS, or yes, PRS. This triangle, if I take, this is a right angle triangle, right? So I can write tan beta is equal to perpendicular by base. Okay, so this is base, this is perpendicular, right? This is perpendicular RS. So perpendicular by base, perpendicular is SR. SR is the perpendicular and base is PS. I hope you are understanding this. Now look, my problem is now what is this SR and what is PS. I have to find out the length of them. Look, if I drop a perpendicular, okay, let me just draw a perpendicular here. Okay, perpendicular means this is the height. Okay, this is actually exactly equal to how much? It is SR. Okay, SR is kind of height, right? So look, this is B vector. If I take the magnitude of this vector B and this angle is theta, then what is this particular? See, I have now this one. Okay, uh, angle triangle. You look this one. This particular thing I have now. So this is 60 degree. This is B. This is 60 degree. Okay, and I have to find out what is this one. Okay. Okay, so what I can write here from this particular triangle, this is also right angle triangle, right? So what I can write about this one, this is S and this is R, and yes, so this is S, this is Q. Okay, so from here I can write actually this RS. See, if I write sine theta, sine 60 degree, sine 60 degree means perpendicular by, so SR by B, so SR will be B sine 60 degree. Okay, that means root 3 by 2 into B. So SR is root 3 by 2 into B, right? What about PS? Now let us write what is PS. So PS I can write as PQ minus SQ, isn't it? But what is this SQ again? SQ from this particular triangle. So this is base, this is hypotenuse. So I can write base by hypotenuse. So SQ base by hypotenuse, that is B, is equal to cos of 60 degree. Cos of 60 degree, right? So I can write SQ is equal to B cos of 60 degree, that is B by 2, right? So SQ is equal to B by 2. See, then I can write PQ. What is PQ? PQ is nothing but A minus SQ is B cos of 60 degree. Okay, that means A minus B by 2. A minus B by 2. This is what I get as PS. So let us put it here. So if I put this PS, okay, so not here. Let us put it here. Root 3 by 2 B divided by PS is A minus B by 2, right? So it will be root over 3B divided by 2A minus B, and this is nothing but tan beta. So what will be tan inverse beta? Sorry, what will be beta? Beta will be tan inverse of that. So beta will be tan inverse of this quantity. Okay. So option A will be the correct answer for this question. Okay. So dear students, I hope you have understood this. If not, see the solutions multiple times, you will understand it. Okay. All right. So go to the next problem. This is very interesting problem. Let us try to solve it. 4 NOR gates are connected. Okay. So yeah. So I think by mistake I have taken this 12th standard question in here. Let us solve it here. Okay, let us solve it here. 4 NOR gates are connected as shown in figure. The truth table for the given figure is what out of this 4? Okay, this is actually from 12th standard. By mistake I have just taken this question over here, but we'll discuss it here itself. Okay, so this is really a fun to solve this kind of problem. Okay, so let us analyze this gate. Okay, so you look, these are NOR gates. Okay, what is the output of NOR gate? Let me remind you what is the output of a NOR gate. Suppose you have two inputs A and B, then your output will be suppose Y1 A or B whole bar. And if you want to further apply De Morgan's theorem and simplify it, you'll get A bar dot B bar. Okay, this is actually the output of a NOR gate. Okay, so with this concept, let us try to write down the output of this one. Look this, let us say this output is Y1, this is Y2, this is Y3, and this is the final Y. Okay, so Y1 will get like this, isn't it? Then what about Y2? Okay, What about y2? Now look, this b is here. In case of y2, b is here, a or b whole bar. Okay, in case of y2, and similar thing for, say this is y2. Let us write down y2. So y2 will be a or b whole bar and bar of the whole thing. Okay, so if you want to further simplify, what you will do, you will do this: a bar dot a plus, like a or b bar and bar of that. Okay, so then you will get actually a bar dot a or b. Now if you do this AND operation, what you should get, you should get a bar dot, like a bar and a, this will always give you 0. Okay, a bar and b, so this will always become 0. Okay, so you get the output a bar b. Okay, so dear students, what we will get here, we will get a bar b. Now let us try to find out what is this y3. Okay, so in case of y3, see y1 has been fit to this, right? So let me just clean this portion. So y3 will be, see, one input will be b, another input will be this one. So y3 will be b or a or b bar and whole bar of this. Okay, so then we get b bar and a or b bar further bar of that. Okay, so this will be b bar and a or b. So now from here we'll get b bar a, b bar b. So b bar and b, this will be always 0, so it will be b bar and a. Okay, so I have got b bar a, or I can write a b bar, a bar b, a b bar. Okay, now look, what about y? What about y? Now I have got y3, y2. I have to get what is y. So see, this is y2 and this is y3, right? And here I will get y. So y is equal to a bar b or a b bar whole bar of that. Okay, then what I should get, I should get a bar whole bar of that dot a and b bar whole bar of this. Okay, if I do that, you look here also, if I apply the De Morgan's theorem, then I get a double bar or b bar. Here there will be AND operation, Okay, here there will be a bar or b double bar. Further, I'll get a or b bar dot a bar b. Okay, now look, if I do this operation, what I'll get a bar, okay, a bar plus a and b, okay, like or a and b, then you get further or a bar b bar or b bar. So a and a bar, b and b bar, this will give you always 0. So you get the output a and b or a bar and b bar. Okay, now look this. Let me write down the truth table here. A, B, and Y. See, if I put 0, 0. So 0, 0, see, that means this will be 0. A and B both are 0. So 0, 0 will give you 0. But this will be 1 and 1. So this will be actually output of 1. Now if I put 0 here, 1 here, so this will be 0 and here also it will be 0 because 0 bar will be 1 and 1 bar will be 0. So this will give 0. This is again 0. Now 1, 1 will give you further 1. Okay. 1, 1 means this one, this A and B will give you the output. Okay. Output, high output you will get. So see, this is given as 4. So this will be actually the correct option for this question. Okay, so this was little lengthy to solve it step by step, but if you can do it quickly, this is best way to do. Okay, all right, we'll go to the next problem. I hope this problem is from 11th standard. Yes, it is actually from kinematics. Sorry, kinetics of gas. Okay, KTC, kinetic theory of gas. A cylindrical container of volume V, see volume is given 4.0 into 10 to the power minus 3 meter cube, contains 1 mole of hydrogen gas and 2 mole of carbon dioxide. Assume the temperature of the mixture is 400 Kelvin. The pressure of the mixture gas is. So you have to find out what is pressure where R is given. So see, in this case, we'll write down the ideal gas equation. PV is equal to nRT. So P will be nRT by V. Look, this N is 3 mole, R is given as 8.3, T is given as 400 Kelvin, divided by V is given as 4.0 into 10 to the power minus 3, right, meter cube. Okay, so from here we'll be able to solve it. Let us try to solve this. Okay, so this will be 100, and if we just multiply 10 to the power 3, so let us put it here. Okay, so we have this one, so 3 9 24, then this one into 10 to the power minus sorry, plus 5, so 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , 24.9 , into 10 to the power 5 Pascal. Okay, so this is actually in Pascal unit. Okay, so option C will be the correct answer for this question. Okay, so let us go to the next problem. Okay, so this is again an interesting problem from the kinematics part. A particle of mass is suspended from, this is from a ceiling through a string of length L. So this is a particle of mass m, okay, and it is suspended from a ceiling, okay, through a string of length L. The particle moves in a horizontal circle of radius small r such that r is L by root over 2. So what will be the speed of, the speed will be, okay, you have to find out what is the speed. So in this case, speed means you can understand that you have to write somehow mv square by r, that is the centripetal force, and what is supplying the centripetal force you have to write down here. So let me just draw this. Okay, suppose this angle total is 2 theta, it is theta, okay, and now look, and this perpendicular bisector of this angle is bisecting the diameter of the circular path also. So this is r, small r, this is L. Now look one thing here, if I just draw the free body diagram, what are the forces acting on this particle at this particular configuration, okay, at this particular position. I'm sorry, let me just give dot line itself. So one is this one, you can see that mg will be acting vertically downward. See, this is the tension which is acting towards this fixed point of the wire, okay, and if this angle is theta, this is also theta, so I can actually see that this t cos theta will be balancing the weight of the particle, and t sin theta here will actually supply the centripetal force. So I can write t cos theta is equal to mg, and t sin theta is equal to m v square by r, okay, m v square by r. All right, now if I see, suppose this is equation number 1, this is equation number 2, if I divide equation number 2 with equation number 1, then what I get? Tan theta is equal to m v square by, so v square by rg, right, v square by rg. Now I have to find out what is this theta first of all, okay. So look this figure I have now, I'm just drawing here. So this is this particular length which I don't know, but this is L, I know, this is R, and what is this angle? This is theta, okay. This you can take as a perpendicular, so this is a right angle triangle. So I can write sine theta is equal to perpendicular by, I'm sorry, perpendicular, you have to take this one, okay. This is base, this is perpendicular, so perpendicular r by L. L is the hypotenuse, so r and L has got a relation. Let me write down this r in terms of L, or L you can write down in terms of R. So I can just do one thing. Let me write down what is L. L is equal to R root 2. So you get sine theta is equal to 1 over root 2. So this implies that theta is equal to 45 degree, because sine 45 degree is 1 over root 2. Now look this here. If I put the value of theta, theta is 45 degree, then I get v square is equal to R g, as theta is 45 degree. Okay, so what will be v? The speed will be square root of rg. Okay, square root of rg. First option will be the correct answer for this question. Okay, all right, so this was medium tough question, but not very tough question. All right, so let us go for this question. Okay, so this question says a bomb is dropped by a fighter plane flying horizontally to an observer sitting in the plane. The trajectory of the bomb is a hyperbola, parabola in the direction of motion, straight line vertically downward in the plane, parabola in a direction opposite to the motion. So you can understand this is actually a vertical, like this is motion in a plane first of all, and then it is actually a projectile motion. Okay, so see, a fighter plane. Okay, so kind of this, so fighter plane. Okay, so fighter plane is dropping something. This is a bomb, right? So it is dropping a bomb. So it is actually, see, the fighter plane is actually flying in the horizontal plane, right? In the horizontal plane. So when it is flying in the horizontal plane, so initially this will have, see, it will not go down directly. This is not the trajectory. The trajectory will be, see, it will have initial velocity u like this. Okay, but since it is motion under gravity, so it will slowly drop the ground. So if this is vertical line, so it will be actually dropping down, making a parabolic path like this. Okay, let me show you the trajectory, kind of trajectory, this kind of trajectory you will have actually. Okay, so if I draw this, okay, so my god, this is, I don't know what it is. Anyway, so you have to imagine that there was a fighter plane, right? So it will have a horizontal velocity initially, so that will actually pull it here up to this distance from the point of dropping. Okay, even though it has g, actually it has two. See, initially it has only u initially, right? But it is the motion under gravity, so it will go in the horizontal direction. At the same time, it will come down also. So in that way, it is actually a parabola in the direction of motion, of the, motion on the plane. So option B will be the correct answer for this question. All right, so this was a very simple question. Now, okay, so this question says, if the length of the pendulum if the length of the pendulum clock increases by 0.1% length of the pendulum. Okay, then the error in the time per day, error in the time per day you have to find out. Okay, so this is not very tough. Let us write down. The pendulum has got a time period, expression for the time period 2 pi root over L by G. G is constant, 2 pi is constant, so I can write actually T is directly proportional to square root of L. Now when I'm trying to find out the error in that, percentage error in that, I have to do this. And in this case of, actually you know this how to do, so you have to take the logarithm, so and then take the derivative with respect to like individual parameters. So here in this case, see, I'll get half into delta L by L. I hope you are understanding, because when I'll take L to the power half, log of L to the power half, this power will come in front, right? And then it will be like this, half log L, and take the derivative of this L in terms of L. Okay, so that will give you half delta L by L. So dear students, you know this this particular the value of this particular parameter is given already. So what you have to find out, you have to find out then the error in the time per day. That means this is given already, so you have to find out what is this delta T. Let me just find out what is delta T by T. What is this? So half into 1%, 0.1%, that means I'll write 100 over here, isn't it? So I get 1 over 2 into 1000 here. Okay, now see, delta T I have to find out, because this is in second. Okay, this is not in percentage, that's why. Okay, so this T by 2 into 10 to the power 3. What is this T? T is actually 24 hour. So 24 hour means, to if I make this into second, then 24 hour into 60 into 60. Okay, divided by 2 into 10 to the power 3. So what we'll get? So if we do this here, 12, okay, all right, so this will be, this multiplication will get you this into 10 to the power minus 3. So 10 to the power minus 3, that means, you know, you will get something here. So nearly 86.8. Okay, 86.8. So I think we can write this one. Okay, 86.2. This is not second pendulum, right? The length of the pendulum, this is not second pendulum. Okay, pendulum. Okay, I hope this is not second pendulum. Let me just check once again. If second pendulum, then time will be 2 into 60 into 60 divided by 2. Yes, I'm sure. So the option C will be the correct answer for this question. Okay, error in this. Okay, so yeah, this is the error. We'll go for the next problem. So this problem says two blocks of masses 3 kg, as you see 3 kg and 5 kg are connected by a metal wire going over a smooth pulley. The breaking stress of the metal is given. Breaking stress. Stress means what? Stress means in this case tension of the wire divided by area of the wire, cross sectional area. That is actually breaking stress. Breaking stress. All right. What is the minimum radius of the wire? Okay, so if the maximum breaking stress, okay, this is the limiting breaking stress, then what will be the minimum radius to have this mass pulley system? Okay, all right. So for this case, as I said, you have to find out the tension in the string. So how do I write down the equation of motion? See, I can write 3 into g. G you can take 10. Let me write for the time being g alone 3g. So t minus 3g is equal to 3 into a. Again, this is 5g minus t, that will be 5 into a. First of all, let me find out what is the acceleration a. Okay, acceleration a, I'm not going to solve this equation to solve this. Okay, you can just do that. So just add these two. So what you'll get 2g here, and here you'll get 8a. So what is going to be this a? A is going to be g by 4. This you can do easily if you just do this 5 minus 3 divided by 3g. These are okay, 5 minus 3 divided by 5 plus 3 into g. So this will give you g by 4. So this way also you can do. Now you just find out the t from the first equation maybe. So t minus 3 into 10. Okay, this is 3 into 10 by 4. Okay, 10 by 4, that means 5 by 2. Okay, so 15 by 2, and here t. So it is, look, this is 15 by 2 plus 30. Okay, 30, that this will give you actually 75 by 2. So we have got what is t. Now so dear students, what we had done so far, we have found out what is t. Now we'll just write down what is stress t by a. That means t by pi r square. So that is actually given here. See, 2 pi by, sorry, 24 by pi into 10 to the power 2 Newton per meter square. 24 by pi into 10 to the power 2. This is what is given. Now look here, this pi I can strike out. Okay, so r square is equal to t by 24 into 10 square. So what is this t? T we know 75 by 2. Let me write down here. Okay, so this 25 is okay, so this will be 4 again. So calculation is getting little tricky. So let me just see what are the options given. Okay, I have been given in centimeter. Okay, here I'm doing in kg and meters. So let me do one thing. I'll just multiply 100 over here. 100. So this will give you 25. So this will give you actually centimeter square. Okay, so yeah, this will be 8 So what I get? I get 25 by 16, right? So this is r square. All right, so then I get 5 by 4. 5 by 4 means what? So 1, then there will be 1, so 2, then 5. Okay, so look this one. 8, 2, so 5. Okay, 1.25 centimeter. Okay, so this is how we have to actually solve this problem. 1.25 centimeter. Okay, let me just cross check once again. Question seems to be 12.5. Let me just cross check once again. So G by 4 is fine. So the 75 by 2 is all right. 75 by 2, I see. So let me check once again. Did I write 75 by 2 here? Yes. So 75 by 2. Well, let me just redo once again and see whether, okay, so we get 24 by pi into 10 square is equal to 75 by 2 pi r square. This pi cancels out. I have to find out what is r square. So r square 75 by 2, 4, and this is 100. Okay, so 25 is a, this will be 4, right? So if I multiply 100, I see I have to, okay, let me, this is centimeter square, then I have to multiply actually 4. All right, so this, I think this will give you correct answer here. Okay, so this will be 4, 20, 25, 25 4 is 100, so this will be here. Okay, further this will be 8, I think 1 2 will be there, 2 will be here. Okay, with 24. All right, I hope it is all right now. This is, then you get 2500 divided by 16. This is r square. This will give you 50 by 4. Okay, so this will actually give you 12.5. All right, so this is, I think this is correct answer. Okay, this is the correct answer because I was multiplying just 100, but I have to multiply centimeter square. Okay, so that was the mistake I was doing. So dear students, I'll stop it here for today with this. Next day, in the next class, I'll take further questions from 12th standard and 11th standard, and we'll try to finish this 26th August shift 2 papers before the next session of the JEE Mains come. Okay. So thank you for your patience. Bye for today.